Today we're going to look at lesson 9.2, which is on exponential functions. So in this lesson, we will evaluate exponential functions, identify and graph exponential functions. So here, scientists model populations with exponential functions, and we can see that in the graph here with insect population. So the table and graph show an insect population that increases over time. So 0 days, 1, 2, 3, it's going 2, 6, 18, 54. Each time the population is growing by a factor of 3. So we're multiplying by 3 to get the next year's population. So a function rule that describes the pattern is f of x equals 2 times 3 to the x power. This type of function in which the independent variable appears in an exponent is an exponential function. Notice that 2 is the starting population and 3 is the amount by which the population is multiplied by each day. So the 2 on the outside is what you're starting with. 3 is how it's increasing each time. Here, the exponential function rule has the form f of x equals a b to the x, where a does not equal 0 and b cannot equal 1, and b is greater than 0. So we're going to start by evaluating exponential functions. So it's going to be really important to have a calculator handy for some of these, because you're going to get lots of decimals that you really can't solve by hand very quickly. So for A, it says the function f of x equals 2 times the quantity 3 to the x power. Models an insect population after x days. What will the population be on the 5th day? So the 5th day means we are going to substitute in 5 for x. So we're going to have f of x equals 2 times 3 to the 5th power. By order of operations, you have to do 3 to the 5th power first. So you're going to raise 3 to the 5th power, and we're going to have 2. 3 to the 5th power is 243. So then you're going to take 2 and multiply it by 243, and you get 486. So the insect's population after the 5 days will be 486 insects. For B, we have the function f of x equals 1,500 times 0.995 to the x power, where x is the time in years, models a prairie dog population. How many prairie dogs will there be in 8 years? So we're going to substitute in 8 for x. So we're going to have f of x equals 1,500 and then 0.995, and the exponent's going to be 8. So we're going to do 0.995 to the 8th power first. So we're going to get 1,500. And this is going to be a pretty long decimal, okay? This is going to be 0.96069304336. And then we're going to take this and multiply it by 1,500. And you get 1,441.039565. In here we're going to round because we're talking about population, so you can't really have part of a prairie dog. So we're just going to round this. So this is a very small decimal, so we'll just leave it as 1,441. And this is prairie dogs. So now there is a check it out problem for you to do. It says the function f of x equals 8 times the quantity 0.75 to the x power, models the width of a photograph in inches after it has been reduced by 25% x times. What is the width of the photograph after it has been reduced 3 times? So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So here, this is going to mean x equals 3. So we're going to have f of x equals 8 times 0.75 to the 3rd power. So we're going to raise 0.75 to the 3rd power to start, and we're going to have 8 times the quantity 0.421875. And we'll multiply that by 8, and you should get 3.375. So then this means our picture will be 3.375 inches wide. In example 2, we'll identify an exponential function by looking at ordered pairs. Remember that linear functions have a constant first difference. Quadratic functions have a constant second difference. Exponential functions do not have constant differences. They have constant ratios. So we're looking at multiplication here. As the x value increases by a constant amount, the y values are multiplied by a constant amount. So for x values, you are adding or subtracting. For the y values, you're going to be multiplying. So this amount is the constant ratio and is the value of b in your function. So f of x equals a, b to the x. So here in this table, x is increasing by 1, and then for your y value, you're multiplying by 3. So that's a constant ratio over here. So when we're given ordered pairs to tell whether or not they're exponential, first start by setting them up in a table. So here for a, these are my ordered pairs. So I'm going to set up an xy table. My first coordinate, -1, 1.5, 0, 3, 1, 6, and 2, 12. For my x values, I'm adding 1 each time. So I have a constant change in my x value. And then for y, I have to figure out what's going on. For exponential, remember, you should be multiplying. So to go from 1.5 to 3, I multiply by 2. 3 to 6, multiply by 2. 6 to 12, I multiply by 2. So this is an exponential function. And the reason why is here we have a constant number being multiplied for our y values. B, we're going to follow the same process. Set up an xy table for your coordinates. So we have -1, -9, 1, 9, 3, 27, and 5, 45. So first I'm going to look at my x values. For my x values, I'm adding 2 each time. And then for y, I have to see what I'm multiplying by. So to go from -9 to 9, I multiply by -1. From 9 to 27, I'm multiplying by 3. And then from 27 to 45, I'm multiplying by 1 2/3. Or you can think about that as 5 over 3. Now, these are not the same multiple here. It's not constant. We're not being multiplied by the same constant amount. So this is not exponential. So now there are 2 check it out problems for you to do. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So first you're going to go ahead and start by setting up a table. So an xy table. So I have -1, 1, 0, 0, 1, 1, and 2, 4. My x values, I'm adding 1 each time. And then to go from 1 to 0, I multiply by 0. To go from 0 to 1, you can't really multiply by anything because anything times 0 is just 0. And 1 to 4, I'm multiplying by 4. So I'm going to put a question mark here because we can't do that. So here, there's no constant number that we're multiplying each time. So this is not exponential. For B, I'm going to set up a table. I'm going to have -2, 4, -1, 2, 0, 1, 1, 0.5. So my x values, I'm adding 1 each time. To go from 4 to 2, I'm multiplying by 1/2. 2 to 1, multiply by 1/2. 1 to 0.5, multiply by 1/2. So this is a constant number that I'm multiplying by, so B is going to be exponential. So now we're going to go ahead and start looking at graphing. So to graph an exponential function, choose several values of x, positive and negative, and 0. So you're going to create an XY table to generate ordered pairs. And then you'll plot the points and connect them with a smooth curve. So here our function is y equals 3 and 4 to the x power. So we're going to start by creating an XY table. So again, pick some x values, positive and negative, and then also 0. So I'm going to do -1, 0, 1, and 2. So first, it might be helpful to have your calculator handy. So first, we're going to substitute in -1. So we're going to have 4 to the -1 power. Oops, not 4 to the 4th power, sorry. 4 to the -1 power. So that's going to give us 0.25, or 1/4. Then we multiply that by 3. So that's going to give us 0.75. So 0.75. Then we're going to go ahead and substitute in 0. So 4 to the 0 power is 1. Whenever we raise something to the 0 power, it'll always equal 1. And then times 3 will give us 3. So 0, 3 would be the next coordinate. 4 to the first power will give us 4. Times 3 will give us 12. And then 4 to the second power is 16. 3 times 16 will give us 48. So some of these coordinates are not going to fit on your graph. With exponential functions, your numbers get really, really small or really, really big quickly. So having a couple numbers like this that are close together give you a good idea of what your graph is. So my first coordinate is -1 and then 0.75, so about right there, 0, 3. And then 112 will actually go off this graph because I count it by ones. And then over here, these numbers are going to get really, really small, but will not cross my x-axis. So I'm going to try my best to sketch this. They're not going to be perfect when you sketch them either. So just try your best to kind of connect your curve. So it'll look something like that. So that is example 3. So there are 2 for you to try. So you're going to go ahead and substitute in some x values and then go ahead and graph. Remember, pick some positive, negative, and 0. So for A, I'm going to create my XY table. I'm going to substitute in -1, 0, 1, 2, and I actually did 3 as well this time because it does fit on the graph. So 2 to the -1st power is going to give us 1/2, or 0.5. 0, 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. And then 2 to the third power will give you 8. So -1, 0.5, 0, 1, 2, 4, and then 3. Oops, sorry. I messed that up. I apologize. Let me go back and fix this. So this is going to be 1, 2, and then 2, 4, and 3, 8 is here. So it's going to get really, really close to my x-axis as you go to the left, and then it's going to start increasing as we go towards the right. So that is what our function would look like for A. For B, we have y equals 0.2 times 5 to the x power. So again, we're going to create an XY table. My x values, I'm going to go ahead and do -1, 0, 1, 2, and 3. So 5 to the -1 power, that is going to give you 0.2 times 0.2 will give you 0.04. So this is a pretty small number. So 0.04. And then 5 to the 0 power is 1 times 0.2 will give you 0.2. And then 5 to the first power is 5. 5 times 0.2 will give you 1. 5 to the second power is 25. And then 25 times 0.2 will give us 5. And then 5 to the third power is 125. 125 times 0.2 will give us 25. So that last point won't fit on the graph. But since 5 was pretty small, I just wanted to check to make sure my next number didn't fit. So -1, and then I'm going to be pretty close to that x-axis. And then 0.2, so again, pretty close to that x-axis. 1, 1, and then 2, 1, 2, 3, 4, 5. So we're going to get really, really close to this x-axis, start coming up, and then it goes up really quick. So that will be our exponential function for b. So now we're going to go ahead and look at example 4. So here we're going to be graphing again, but this time our a value is going to be less than 0. So now you see that we have a negative value for a. So what that's going to do is going to open up, have our exponential function be in the lower quadrants, which is why my graph looks like this. So it's going to be in quadrants 3 and 4. So we go through the same process. We substitute in x values to get our y. So again, pick some positive and negative. So we're going to do -1, 0, 1, and 2. So here, -1, so 2 to the -1 power, that is going to give you 1/2 or 0.5 times -5 will give you -2.5. 0, 2 to the 0 power is 1, so 1 times -5 will give me -5. And then 1, 2 to the first power gives me 2, times -5 gives me -10. And then 2 squared gives you 4, times -5 will give you -20. So this last coordinate won't fit on my graph. So -1, down 1, 2, and then 1/2. And then 0, -5, so 1, 2, 3, 4, 5. And then 1, 1, -10 will be over here. So if you want, you can, since this point's not really close to that x-axis, you can go ahead and substitute in -2 if you want. So I'm going to go ahead and put that in as a bonus 1. So 2 to the -2nd power will give you 0.25. And then times -5 will give you -1.25. So if you want to get another point in there, you can. But what's going to happen is it's going to get closer and closer to the x-axis as you go towards the left. So let me try to sketch the best of my ability to connect my points. So that is what your graph will look like. And also, you can always go to desmos.com to graph these as well to make sure you're on the right track. And you can also use a graphing calculator. So now there are 2 check it out problems for you to do. So go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. So for A, we have y equals -6 to the x power. So this negative is on the outside. So you're taking 6, raising it to the power, and then multiplying it by -1, okay? So keep that in mind when you're substituting in. So I'm going to pick some x values. I'm going to do -1, 0, 1, and 2. So 6 to the -1 power is going to be 1/6, and then the negative version of that is going to be -1/6. And as a decimal, that's -0.16, and that 6 repeats. So it's a pretty small number. And then 0, 6 to the 0 power is just 1, and then I have the negative sign, so -1. 6 to the first power is 6, and then the negative sign, so -6. 6 squared, 36, then we get -36. So I'm going to have -1, and then it's pretty close to the x-axis, and then 0, -1. And then 1, -6. So this kind of gives you a good idea of what's going on with your graph. So it'll look something like that. And again, it's not going to be perfect, but it gives you generally a good idea of what this exponential function will look like. For B, we're going to follow the same process, set up an XY table. So I'm going to go ahead and pick -2, -1, 0, 1, and 2.
We have 3 buttons.
So 3 to the negative second power
734 and 713.
will give you 1 9 times -3 will give you negative 1/3. Okay, so -2 goes with -1/3. And then -1, so 3 to the -1 power will give you 1/3 times -3 will give you -1. 3 to the 0 power is 1 times -3, -3. 3 to the first power is 3 times -3 gives you -9. And then 3 to the second power is 9 times -3, -27. So this last point won't fit. So -2 and then -1/3, -1, -1, 0, -3, and then 1, -9. And then from there, connect your points to form your curve. And just try your best to connect your dots. So now we're going to go ahead and look at example 5. For example 5, we are going to have a B value that's in between 0 and 1. So that means we're going to have a fraction or a decimal for the value that's being raised to the power. So for these, we're going to follow the same process, substitute in some values for x, and then go ahead and graph them. So I'm going to set up an XY table. And remember, when you're picking x values, pick some positive, some negative, and also always substitute in 0. So I'm going to substitute in -1, 0, 1, and 2. So 1/2 to the -1 power is going to give you 2. And then 2 times 3 will give you 6. So -1, 6 is my first coordinate. 0, so 1/2 to the 0 power is 1, times 3 will be 3. 1/2 to the first power is 1/2 times 3, which will give you 3.5, which equals 1.5. And then 1/2 to the second power will give you 0.25 times 3 will give you 3/4, which equals 0.75. So -1 and then 6, 1, 2, 3, 4, 5, 6, 0, 3, 1, 1.5, and then 2 and 3/4. So you should notice, so I'm going to connect these before I show you or explain what you should be noticing, that this time my graph is opening in a different direction. Okay, when your A is in between 0 and 1, and it's a positive B value, it's going to open up this way. Okay. B, we have -2 and then 0.4 to the x power. So follow the same process, substitute in some x values, and then get your y. So I'm going to substitute in -2, -1, 0, and 1. So starting with 0.4 to the -2nd power, you're going to get 6.25 times -2, and that will give you -12.5. -1, so 0.4 to the -1st power, that'll give you 2.5, times -2 will give you -5. So -1, -5. 0.4 to the 0 power is 1, times -2 gives you -2. And then 1.4 to the first power gives you 0.4. And 0.4 times 2 gives you -0.8. So -2 and then -12.5 will be, let me scoot this up so you can see it, -12.5 will be pretty far down here. And then -1, 1, 2, 3, 4, 5, right here. So -1, -5, and then 0, -2, 1, negative 0.8 will be about here. And if you want to go ahead and do 2, you're just going to get a smaller number. It's going to approach the x-axis. So I'm going to go ahead and connect these dots to form a curve. So that is what your exponential function would look like for b. So now there are 2 check it out problems for you to do. So go ahead, take a moment, pause the video, and resume when you are ready to check your answer. So start by creating an XY table. So I'm going to set up an XY table here. I'm going to substitute in negative 1, 0, 1, and 2. So first, starting with 1/4 raised to the negative 1 power. That's going to give you 4 times 4 will give you 16. So negative 1, 16 will be really far off the graph. Let's try 0. 1/4 to the 0 power is 1, and then times 4 will give you 4. And then to the first power, 1/4 to the first power is 1/4 times 4 will give you 1. 1/4 to the second power is going to give you 1/16 or 0.0625, and then times 4 will give you 1/4, which equals 0.25. So negative 1 and then 16 is going to be really, really far off the graph here. So that's 11, 12, 13, 14, 15, 16. So about kind of up there. You don't have to include that point on your graph, but just know it's going to be up there pretty far. And then 0, 4, 1, 1, and then 2 and 1/4. So connecting those to form our exponential function. Now you have the option to scale your graph by 2 if you want to include negative 1/16 on your graph a little bit better. So you can definitely do that. Just scale your graph. For B, set up an XY table. I'm going to substitute in negative 1, 0, 1, and 2. So 0.1 to the negative 1 power, that's going to give me 10 times negative 2 will give me negative 20. 0.1 to the 0 power is going to give me 1 times negative 2, negative 2. 0.1 to the first power is going to be 0.1, and then 0.1 times negative 2 will give me negative 0.2. And then substituting in 2.1 to the second power is going to be 0.01 times negative 2 will give you negative 0.02. So you see that it gets pretty small pretty quick. So here, I'm going to scale this one by 2 just so you can see it a little bit better, but keep my x-axis scaled by 1. So this guy is going to be negative 20 down here. And this would be positive 4, so 2, 4. So negative 1, negative 20 is all the way down here. 0, negative 2, and then 1, negative 0.2, and these guys are going to get closer and closer. So my graph is going to get really close to that x-axis pretty quickly. And I didn't do the best job of drawing that curve. I apologize. So your exponential function will look similar to that. So now there is a note in your book that just reminds you of some things and some observations that you should have made with the general shape of exponential functions. So here, if b is greater than 1, the graphs will either open up or kind of open down starting from the left side. So they'll get really, really close on the left side and then shoot up onto the right, either up or down. It'll go up if a is greater than 0, down if a is less than 0. If b is a fraction or a decimal, your graphs are going to start off really big and then get really, really small as they go to the right. If a is greater than 0, it starts off big, gets really small as you go to the right. If a is less than 0, it starts off really small, and then it gets really, really close to 0. The last example, example 6, is using your graphing calculator. If you don't have a graphing calculator, again, you can use Desmos.com to help you graph and answer these questions. So in year 2000, the world population was about 6 billion, and it was growing by 1.21% each year. At this growth rate, the function f of x equals 6 times the quantity 1.0121 to the x power gives the population in billions x years after 2000. Using this model, in what year does the population reach 7 billion? So, in your graphing calculator, okay, you will hit y equals to type in the function. So 6 times 1.0121, and it's to the x power. Okay, and then you can hit enter. Then you'll hit second graph so you can get the table. So here is your table. And you want your y value, you're going to scroll down until your y value gets as close to 7 billion as possible. So I'm going to start scrolling down. And whatever x value that is, that will be the corresponding y value. So here 12 is 6.9316, and then 13 is 7.0155. So 13 is as close as we can get. So y equals 13, which means year 2013. Okay. Now there is a check it out problem for you to do. You're going to use your graphing calculator, so go through that same process, enter that function in. So in your calculator, you're going to go back to y equals, clear that out, and then you can type in your function, and then go back to second table. So take a moment, pause the video, and then resume when you're ready to check your answer. So I'm going to go ahead and enter my function. So 12,330 times, in parentheses, 0.869 raised to the x power. I'm going to hit enter. Then second table, and it picked up where I left off, so I can scroll back up to 0. And I want to figure out when the car will be worth 2,000. So I'm going to scroll through these x values here and see when I get close to 2,000. So keep on going. So here at 12, I get 2,286, and then 13, 19, 1,987. So it's very close to when x equals 13. So that means after about 13 years.